Is it working?
Yeah, you're live.
Okay, I'm live. So, hi guys, my name is Jason, and we're gonna be learning about database management systems with PostgreSQL. I have to be very particular about using the word DBMS because when we start going into the demonstrations, you're gonna get confused if I just call it a database, which is not. A database management system, it just allows you to manage databases. So what we'll be doing is using Postgres to create a database, which I've already done, and then just do stuff with it today to introduce to you like how to use a database management system and just like basic queries that you can run. Yeah, all that disclaimer, blah, blah, blah. So yeah, this is the agenda. What is a database management system? How do they work? Very simply, different kinds of SQL, installation GUI. You don't need to follow along with the installation and all that kind of stuff. You can do it on your own time. You don't really, I want to make it more accessible and do different types of SQL commands, DDL, all that blah, blah, blah. And we're going to look very briefly at indexes. Yeah. So a formal definition, really, you can just check it in Wikipedia. But I think a layman's definition for people who are just like unfamiliar with relational database like this is just a software specialized in storing and retrieving data just extremely quickly. Yeah, that's essentially what it is. Yes. So a database management systems allows you to just like create and delete databases, and inside a database you can define like strict ways that you can store and retrieve data. Yeah. So think of a database as just like a set of rules on how data is supposed to be stored. I think last week when Beach did a presentation on NoSQL, I think he may have mentioned that in NoSQL you can just kind of shove anything into the database and then they'll be just like, hey, that's fine, I'll just take it. But in a relational database like PostgreSQL or MySQL, blah, 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 you can't do that. They will throw a fit. They will just not allow you to do that. They want you to be sure exactly what you're going to put in first, and they will only accept that kind of data. So yeah. So how do databases work internally? It really deserves a whole workshop on this topic alone. It is just a lot of C and C++ and lots of like weird data structures like pages and cursors and just like indexes and all that kind of stuff. And there have just been decades and decades of optimization to make it just go really, really, really fast. And that just, and those people make our jobs really, really easy. So, and that's just know that it's really complicated and it's a bunch of like C and C++ code and nobody really likes reading that kind of code. So, blah. Yeah. So, yeah, SQL, PostgreSQL, MySQL. I'm going to be using PostgreSQL as an example for this workshop because I've been using PostgreSQL professionally for about 2 years. It's something that I'm most familiar with. But the basics of SQL, like between like all the different like SQL dialects, they're called dialects, like Oracle SQL and MySQL SQL, PostgreSQL, and a couple of others, they are just very, very similar. Like the simple, like, the selects, the creates, the updates, the inserts, they're all the same. And how it is run and interpreted by each database management system is slightly different, but that is really, outside the scope of this workshop. So if you just learn the basics, you will be able to just, use any kind of database. When I was personally learning SQL, I just learned using resources from Oracle, MySQL, PostgreSQL. I just used them to learn because in the end, they were just all the same, right? So don't be too picky when you're just finding practice material online. Yeah. So there are multiple ways of installation if you want to try. I personally use Homebrew, and I've taken to using Docker recently when I need the multiple databases. Just Homebrew is you can just install through the command line, just like brew install PostgreSQL @ 14 or 15 or 16. That's the version number. You can use Docker, Docker up, Docker compose, blah, blah, blah. Or if you're just using a Windows computer, you can just download a .exe from the websites and just run that. There are just many ways to do it, and there are many, many tutorials online. I just followed anything that I could find, and yeah. I recommend that if you want to do like a not really mess up the installation, make sure to just if you do want to follow along, just delete any like instances or just of the program in your computer and just like do it from scratch. Yeah. I personally did this, and yeah, brew install PostgreSQL add 14, blah blah blah, and then Homebrew allows you to just like run the programs that you download as well. And so I use the command brew services up PostgreSQL add 14. Am I going too fast? Okay. I think when I installed it, 14 was the latest one. But you can use 15 or 16. The differences are minimal. It doesn't really matter. Yeah. When we get to the actual like demonstration stuff, I'll slow down a bit more. So PostgreSQL, it doesn't, to my knowledge, come with a convenient graphical user interface that allows you to just like create tables and all that. I think there is something called pgadmin, but I don't really use it because it's quite inconvenient. Is anyone following along with the installation? Okay. I'll slow down a bit. Oh, what do you mean by comma? Command. So this is the first command. Yeah.
The first one installs it?
Yeah.
The second one starts it?
Yeah. Yeah. Following along is optional. It's fine. Any questions so far about what I've said? No. Can I move along or? All right, cool. Thanks, Beach. So as I said before, there isn't really a graphical user interface that comes with PostgreSQL to my knowledge. pgadmin, I don't think it's official, but yeah. So I've been using something called dbeaver and datagrip. dbeaver is the free open source version, and datagrip is the paid one by IntelliJ. You can use either of them to connect to a database that you have online or offline on your computer. And then you can just run queries and just create schemas and create tables and all that kind of stuff. For demonstrational purposes, I will be using both a GUI and both just a terminal to do that. And
Real quick, for your last command, brew services start.
oh yeah.
Can you say that just quickly?
Yeah. So it's brew services start. Yeah, that was a typo. Yeah. I think I got it confused with Docker. Yeah, not Docker up. Yeah. So yeah, these like GUIs aren't really just necessary. I just prefer to use them. And honestly, just to show you, I'll do the commands in like a terminal as well to show that you don't really need these. This is just to make it prettier on the eyes and just easier to use, just like really quality of life. Yeah. And this isn't really a tutorial on how to use this kind of software. And it's just like, this is mostly a demonstration on how Postgres can be used to demonstrate SQL. Yeah. So there are key database properties that all relational databases use to make sure that the data is is like consistent. First is atomicity, second is consistency, third is isolation and durability. Starting from the bottom, durability is the most simplest to explain. It just means that after you put in the data, after it's saved, if you turn the computer off and turn it on again, the data still has to be there, right? The data has to be durable. If they turn the computer off and then turn it on again, if the data is not there, then the database is not durable, right? Going from the bottom up again, isolation. So the users of the database, like the user of the database server, which is mostly like a backend server somewhere, it can connect to the database multiple times. So like 3 or 4 different connections at the same time. And all these connections can run queries. And these queries must not like interact with each other in any meaningful way. They have to be run in isolation, all separately, right? So the query running, so query 1 and query 2, if they're both running at the same time, they should really not interfere at all, right? This is the concept of isolation, right? And consistency. So the database, this aspect of consistency, it's going to be more apparent when I start showing you examples. Because when we before we start putting data in a database, we have to say that this table is going to contain this kind of data in this kind of type. And that kind of consistency must not be broken. So the rules that we set about how the data is supposed to be stored must not be broken. So that is the aspect of consistency. And the final one, atomicity. So this I'm going to elaborate on more when I talk about like transaction control languages. This just basically means, like right now, to put it very simply, every kind of query that you run, it must either fully succeed or just nothing should happen at all, right? So it either runs successfully or it just does not happen at all. So if you try to update something, but then something goes wrong, then this update will not happen at all, right? So this prevents like incorrect data or that kind of stuff from being stored in the database, which relates to the consistency part. Does anyone have any questions? Okay. Is any of my explanations not clear? Okay. See, I told you databases were going to be boring. Yeah. So yeah, there are 5 main query types. Data definition language. This relates to first creating like the schema or the rules in how data is supposed to be stored. So this relates to creating a database or dropping a database, creating tables, creating schemas, altering those tables and schemas, and just like completely deleting everything with truncate. Data manipulation language. You insert data, update, delete. That's just, if you're fluent in English, I mean, these verbs should be pretty self-explanatory. Data control language, I think. So a database can have many users. So a database admin would be able to do everything. A backend engineer would be able to, would be able to insert, update, and delete and select. But a business analyst or like a data analyst, they would only be able to select, right? And this is the kind of stuff that the data control language allows you to do. So you grant someone the ability to select in this kind of schema only, right? And this would be mostly the job of a database admin. I will go into actual details and all that kind of examples later. So transaction control language. So this transaction control language, it relates to the atomicity and the consistency part. So this makes sure that that when a transaction is begun, you can always roll back to a certain point, and you can also make a save point. I've personally never used a save point in my career. I don't know why it's there, but if anybody knows, then just please tell me. I've used commit and rollback. I will also just show this in an example to make it just very apparent what it is. And finally, select. Yeah, you can just, sometimes you don't really need to know all of this, right? Like all of this is just a lot of stuff. I mostly started by learning select, because select itself is just like queries to extract data is an art itself. There's just a lot of things that you can do, and it can get very, very complicated. And once you really learn select, everything else is just very, very simple. So I will start with the simpler stuff first, and then finally talk about select, because literally, like some jobs, like I was a business intelligence analyst for like a couple of months, and the only thing I did was just run select queries every single day, 8 hours a day for like 3 months, and that's like how deep you can go into select, right? So yeah, data control language, the simplest stuff, useful for, I guess, database administrators. I talked about granting and just revoking privileges on selecting and just creating, updating, deleting. Do I have examples for this? I probably don't. Hold on. Hold on, no. Okay. So this is, hold on. Yeah. I don't think I have examples for grant and revoke because I've just barely used it. But know that the example that I've used of allowing certain users to select in only certain kind of like schemas or tables, that exists for the protection of the database. You don't want the data scientist or data analyst to put stuff inside databases without your knowledge, and this is what grants and revokes do. And I think this is really in the area of database administrators. I haven't really, I'll not really be able to just I think explain too deep about this. And revoking, I think it's what the verb says. Oh yes, question.
So,
Mhm.
as the life of the database goes on,
Yeah.
is it possible to track all the actions that's been made to a user or as people or anything? Just kind of output.
To my knowledge, I think there is. Yeah. I think all databases do have them so that the states can be rolled back if needed. Yeah, but
Not sure what the default is. You do need to configure it. So for whatever database you're using, I recommend checking the login configuration available.
yeah, yeah.
Can you repeat that for the screen?
So what Beach said is that you do need to configure some kind of logging for each database, and that's the way to just track what kind of users are doing what at what time. Yeah, this is mostly kind of like security stuff that I'm not really that familiar with, right? And if you're using like a database, I think that you'll just really rarely use these kind of things unless you work in like a really big organization where like data access is just very restricted. Yeah, and in that kind of situation, you do have to kind of use this kind of stuff, right? If you are following along, you can run these commands in a terminal, in just a terminal here, like PSQL, Postgres. What this means, right? PSQL means let's go inside the PSQL like repo, read, evaluate, print loop, and as the user Postgres. Bigger. Oh, hello. How do I? Hey. Okay. Yeah. PSQL Postgres to go inside to access the database as user Postgres. Postgres is the default user that comes with Postgres when you first install it, so that you have like a user to do stuff with. Yeah, PSQL Postgres. You're inside the PSQL loop, repo loop. I ran these commands, right? You can create a user JSON with encrypted password. Yeah, don't actually use 1, 2, 3, 4. Yeah, just please don't. I mean, super user just basically means admin that can do everything. Yeah. I created a database called e-commerce, and I gave the owner to JSON. That means like if someone else than JSON tries to connect to the database with like other credentials, they won't be able to like do stuff with it. And then, yeah, and there are just a couple of commands. What this thing does is list databases. So I created this, and the owner's JSON, and all shows all that kind of stuff. And this is this Postgres and template. This was there when I just first installed Postgres. So yeah, it's there. And to connect to a specific database, you do this slash, and then you type out the name of the database, and you say, wait, hold on. Huh? Uh-huh. If you change the owner to someone else, to another user with like actually secure password, I think it would be okay. Yeah, because right now it's just the owner is admin, right? So I think it would be easier for like anyone to like just hack into it if the like database port is just exposed publicly. Yeah, which you don't want it to happen. Hold on. Yeah. Oh yeah, it's connect. Sorry. Oh, did that answer the question? Okay. Uh-huh.
For people following along,
Yeah.
installing the Postgres formula on brew does not install a PC client. They need to install.
Okay.
They need to install another formula called libpq.
libpq. Okay. Yeah. If you are following along, you can also install something called libpq. Yeah.
Why?
It doesn't come with PostgreSQL by default, and yeah. Another question? Yes. I'm actually not sure what they do. Yeah, but I've never had to use them. They're just there for whatever reason. Let me actually check what it is. Template. In the Postgres database, in the public schema. Come on. Huh. I think this is all of the internal stuff. Yeah. I think template may be one of them. Yeah, so I usually don't touch the default stuff, just to be safe. Yeah, I'm gonna give people some time to follow along if they need to. Yeah. So after creating the database e-commerce, I made the schemas not Coupang and not Amazon. They are legally distinct from Coupang and Amazon. So, hello. Mm. Yeah. Yeah. Oh, okay. So like a running backup, something like that. Okay. Yeah. So an easy way to think about SQL commands, it is very different from programming. Programming is imperative. So like most kind of programming that we do besides the functional stuff, you say, oh, first I'm going to declare an array, and then I'm going to push it inside if the size is smaller than 10, blah, 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 blah. You have to think of every single step imperatively. But for SQL, it's just like, speaking to a person or just like speaking to ChatGPT, just do something for me. Just like declare what you want and just according to the SQL rules, and then the database will just do it for you. So all these commands, it's almost like English, like even more English than Python, which is also like pretty much just English. Yeah. So if you have like primary school, if your English is better than the primary school level English, SQL is gonna come very naturally to you. So just don't think too hard about it. So yeah, gonna give some more time to people. And you don't have to follow along. This is completely optional. It's fine. Like. Hold on. Let's cause an error, right? We already know that not coupang is already inside the database, right? Inside e-commerce, we have not coupang and not Amazon. Let's try to see what happens if we try to create a schema again. Create schema, not coupang. Oh, question. Schemas, it is, hold on. I do have to, yeah. So a database schema is like a blueprint that defines the structure of a database. So including like tables, fields, relationship, and constraints. So, and indexes. So it provides somewhat of a framework for organizing data, right? And you can't, I don't believe you can just create data like tables inside databases just willy-nilly. You do need a schema that says, that just basically shows that this table is related to that table in that kind of way, right? Yeah, to my knowledge, yeah. Yeah. Yeah.
It makes access control easier.
Yeah.
It makes logical organization easier.
Yeah.
Also, different databases can run different engines.
Yeah.
For example, the Postgres database management system has various different engines to support different use cases. For example, it has like a geo database engine,
Yeah.
or a time series database engine.
Yeah.
And that's done like per database per schema kind of thing.
Yeah.
There's also the idea of a table space, which is how the data is stored on the physical disk,
Mhm.
which can be controlled at the schema level.
Yeah.
Does that help? Yeah. So in this case, not Amazon and not Coupang, it's like standard practice to name it like not something.
No. This is just a joke, right? Yeah. I just wanted to do something e-commerce themes, and then I was thinking just, I don't know, let's name it Coupang and Amazon, but legally distinct. So, yeah. I just named it like that. Yeah. And this would be like, I don't know, like a logical like schema difference instead of just like the technical one. Because when you create actually if you create like extensions on Postgres that expands the features. So in my case, my company uses a lot of like geospatial data. So we have to install like a geospatial like extension on Postgres. What that kind of thing does in each schema, right? It installs the all of the data types that's involved with all the geospatial kind of coordinate data, and it just creates like an extra table and all these kind of new types, and it's all stored inside per schema. Yeah. And for like access control, that's related to grant and revoke. The data scientist in my company, he has like his own schema where he can create all these kind of temporary tables, and he's only allowed to have access to that kind of schema, so that he can do everything he wants without having access to the actual production database schema, which is called something else. Oh yeah, Smatch. Yeah, I'm not able to show this kind of stuff obviously, but just yeah. Oh, by the way, this table has like 10 million rows, and I'm going to show you how indexes can make things faster or slower. So yeah, it is crazy. Did everybody? I think people had sort of enough time. Right. So, yeah, data definition language. You define how the language is going to be stored. And I personally use this quite infrequently. First time when you're setting up a server, like project, you create all the database and all the database schema all at once. And you use the create command for that. Right, hold on. All the create commands for that. I will go into detail a bit later, but this is how the create looks. And honestly, this is kind of a pain in the ass to write. So what I usually do, right? This is just all quality of life stuff. Quality of life, all that kind of stuff. So you can define columns, new column, integer, blah, blah, blah. So this is what I normally do. You can also type it all out to like practice, but I don't think you really need to like learn and all this kind of just properly memorize all this because, you know, if it's simple enough for a computer to just render out the SQL, right, you don't need to really memorize it. I think you just need to understand what the SQL means, to be honest. So yeah. After you create the table, you may decide to just completely drop it because you're just not using the database anymore. Got something in my throat. Let's say you were storing like user login data for whatever reason, and then after a while, the login logs, and you don't need to use it anymore. You can use the drop command, drop table if it exists, and then the alter command to alter the table. So first, you may decide that the table contains like this many columns, but you want to add a column or remove a column. You will use the alter command. I will show examples, more detailed examples later, but I'm just giving overview. And truncate. Truncate is a table level, just like deleting of all data. But if you remember, there is also a delete command here. When I get to the delete section, I will explain a further difference between these two commands, right? Yeah, so this is just basically just very simple verbs that you'll be using to just define data. And just how it's going to be stored per schema. Yeah. So when we think about creating tables in databases, right, you can just create one table to shove everything in. And in some cases, that's going to be very useful, right? Just having one table so that you can just run one select to select everything that you need. It could be arguably faster to do that. And just you'll be easily able to optimize queries. But the keyword in database is relational. They are called relational databases for a reason. You can organize data in such a way and then relate them so that data duplication does not happen, and just the like data can be stored more logically. Like right now, we can see that Joe and Sue both have the skills Python and SQL. This data is duplicated. The data called department is duplicated in IT and IT. And it says the manager is Sue and the manager is Janet, right? All this kind of flat data structure can be useful in some cases, right? But we can use many different, mainly three different ways to just split this apart and put them into tables, so that the data duplication is just removed and all that kind of stuff. So there is one-to-one and one-to-many and many-to-one and many-to-many. And what this means, right? This table here, it can be decomposed into these four parts, right? And this is just an example. We can see that Joe is in department 1. And when you go to the department table here, you can see that department, the ID, this is called the ID. it refers to IT. So if this department name changes to, let's say, engineering, right? The data here doesn't need to change because it already refers to the row here. But if it were this kind of table, right? If the department name changed to engineering, that means all of the data that says IT needs to be changed to engineering. And that is just a lot of work and just really not that kind of efficient because data is duplicated like this, right? And this is a one-to-one, if I'm not mistaken. And as for skills, this would be a many-to-many relationship. So many employees can have many skills, right? That's why it's a many-to-many relationship. And we can see that Joe has an ID of 1, right? Joe has an ID of 1. And his skills are 1 and 2. And if you look at the skills table, we can see that the skills for 1 and 2 are Python and SQL, right? Python and SQL, Python and SQL, right? So if, and so the data is not duplicated again, which is very important. We can see that Sue, with the ID of 2, has all these 4 skills. And when you refer to the skills table, it is a 1, 2, 3, 4. You can see that she has all these 4 skills, right? All that kind of stuff. And this is how like the relation part of a relational database works. You create multiple tables and all these IDs that points to each different table to show what the data actually is, right? And all of this, oh, okay, question?
Do you always aim for maximum normalization?
That depends. Really, basically on the feature, on the use case. In some cases, I think like data duplication is fine, but in some cases, no. But most of the time, we would aim to just normalize like this, right? Because if this was just like 1,000, maybe if there were like 1,000 employees, and there's just a lot of data to update whenever there's like a change in data, it would be a massive update statement, and that update statement would just take ages to run. And long-running queries are expensive, and it could just eat up resources in your database that just could be used for something else, right? Yeah.
So to
Yeah.
add to it, you can go back to that one, the denormalize.
Yeah.
If I want to query for software architecture, how do I do that?
Oh, yeah.
In this schema, the skills would just be a giant string,
Yeah.
right? So for indexing, which you haven't gotten to yet,
Yeah.
that whole string would be indexed. So if I wanted to find just the software architecture part, it has to look through each individual one and look for that substring within the larger string, which is painfully slow.
Yeah.
But when we have this many to one, or really many to many relationship, I can just search for the software architecture record in skills, and then I can just do direct lookups based on the ID, and that's fast. So by splitting up the data like this and having individual records for duplicated data, it's faster to find for both that individual record and then faster to find the related records. Does that make sense?
So what Beach said is by splitting up the data in the example of finding skills, right? If you want to find the software architecture, you have to find the substring of every single like skill. And that is painfully slow, which I will demonstrate later with the 10 million row table. But if we use if we use just numbers and indexes, which I will explain later, they're just all related relational databases, haha. It is much faster to find. Yeah.
So in this page, I guess like all the IDs basically mean
Yeah.
something.
Yeah.
You've abstracted.
Yeah.
What do you do about the null?
What do you mean null?
How would you know if it's like, I think it's what we just know what it was strings.
Uh-huh.
Would you have like, if the department, for example, for whatever reason,
Yeah.
said null,
Yeah.
would you know that it just means that there's no department because it's in the department slot in the string?
So,
Like, how do you abstract the meaning from it?
so null is not a string.
Yeah. It is a data type.
Null is a special value. Means there's no value.
Right, but then how do you know? Like,
You filter for null. Yeah.
then how would you know if it's department is null or manager is null?
I will get to that. That's the beauty of select queries. Yeah. It's all related. Yay, like relational databases. Woohoo. Yeah. So, to go into more detail about the create statement. In general, when you're creating stuff or just altering things, it is best practice to put if not exists, right? Just in case that if something doesn't exist, like Postgres or the database just doesn't throw an error. Let's say, you're building a new feature, and as a backend engineer, you're building a new feature. You have to create a new database. No, you're not creating a new database. You're adding a new column to a database that will use the alter keyword. And because your project manager is not good at his or her job, they give one engineer a feature to delete a table, and another engineer to modify the table. And for some reason, the engineer that was involved with just deleting the table merged the PR first, and the database migration happened, and the table is no longer there, right? If you don't have the if not exists keyword in the alter statement, when your PR gets merged, which it shouldn't, but if it does, and that migration is run, the database will just not really check if the table is there or not, and then just run the query and just cause an error and all that kind of stuff. And the database is not going to be happy, right? So it is just best practice just to put in these 3 words, if not exists. This is just real good quality of life, right? So here I'm creating a table called just in the not coupon schema called customer. I'm creating an ID with the data type UUID. Does everyone know what a UUID data type is? Yeah. So hold on. UUID. Yeah. A universally unique identifier, a 128-bit label used for information in computer systems. So it's something that looks like this, right? And this is used as a unique identifier for this table. For this example, right, we use numbers, but it doesn't always have to be numbers, right? It can be a UUID as well, right? As long as it is unique, right, it's fine, right? We can see that this table also has email, name, and password. They're all the type varchar, just so like a string of characters, and it's exactly 50 characters long. So if you try to put in an email that is bigger, that's longer than 50 characters, it will raise an error. And yeah, alter table. Yeah, each table can have an owner, and I changed the owner to Jason. So yeah, basically the super admin, right? Yeah.
So in the exact situation,
Yeah.
you
Yeah.
manager and
Yeah.
ultimate author, right?
Yeah.
Is it better practice to alter the table
Uh-huh.
or create a new table? Because over here we are creating a new table, create table if not exists,
Yeah.
right? But you can also create a new auxiliary table that has references to the whole table if you want to add that column, right?
So
Or would you rather alter the original?
that's a big fat it depends. Database modeling is a very big topic that I don't think I have enough time to cover if I want to cover everything that I've planned. I don't know, what kind of data are you trying to store? I mean, what's the feature that you're trying to develop? I mean, I don't know. I mean,
Well, it could be anything, any column that you want to add to the existing column, right? So the question is, would you rather alter the existing table or create a new table?
I mean, that's like asking, I don't know, would you use a radio button or a checkbox? Like in UI, you know, it just depends. Yeah, Beach. What kind of thing are you trying to build? If I know what you're trying to build, then I may be able to answer the question. But like,
So
yeah.
it's very rare that you want to do a live update unless your database is small.
Yeah.
Because often it will cause database locks.
Yeah.
Now, depending on the engine that you're using, adding a column can be inexpensive and fast. But if you're adding an index, then you're going to have a bad time. A common practice is to make a new table, sync the old data to the new table, and just keep syncing, and then when you're ready, rename the tables, and then you're good. But that's quite complicated. That would be a more advanced thing, and I think you can talk about it more later.
Yeah.
Does that answer your question for now?
Perfect. And also, I have a follow-up question.
Uh-huh.
So, in development, can you go to the next slide? Yeah. So you mentioned an example of backend developer developing
Yeah.
stuff.
Yeah.
To update or add columns
Yeah.
or something.
Yeah.
As you develop, you want to say recreate a database. What's the most efficient way to recreate a database, like reset it? Because sometimes you have references, right? So, for example, not have to find this customer and reference another one, and you have to run deletes or this kind of stuff in the right order, so it actually deletes the table, right? The cascade of things.
Yeah. So let's say this is what I would do. This may not be the most efficient. Are you saying you want to recreate a database locally?
Yeah, locally for development
Yeah.
purposes.
Yeah. So what you can do is after you've like maybe connected to something like this, right? I guess that also really depends on what kind of like ORM that you're using, the object relational manager kind of like package that maps the data models in your code to the database. That could have a feature that just recreates the database for you as long as it has a database connection. That kind of feature works. But in like a pure like SQL way, for this purpose, I think DataGrip has a convenient feature called SQL scripts. It says generate DDL to a query console, right? So the data definition language for all these tables that I've selected will be generated into a query console, something like this. Yeah. So you would make a local database, and then you would use like a GUI like this that has this like convenient feature, and then just copy all of this data definition language, and then just run it on your local computer.
Yeah, but the problem is that once you have something like this, right,
Yeah.
you run it,
Yeah.
all the tables inside,
Yeah.
and then you want to put this extra column in local table,
Yeah.
and you want to recreate the whole database because you want to start from state 0.
Yeah. Yeah. Yeah.
So how would you then delete all the tables without any framework? You just have the SQL, right? So how do you do that efficiently? Because best way I know is that you just run delete statements one by one in the right order, but the problem is the order might not be obvious.
So this goes into kind of deeper stuff. There are commands to just remove all the constraints in a database. So all of the foreign key constraints, all of that kind of stuff. I mean, this is all like local development, right? You don't really want to do this like willy-nilly on like a production database because if you do that, the CTO will probably shoot you. There are ways to remove all the constraints, remove all the data, and then just drop everything. And you can do like meta SQL that generates SQL. So you can create a command, right? Hold on. what?
Talking about dynamic SQL?
Yeah, I mean that's answering this question. But like basically, you can create SQL commands that introspects the PostgreSQL like metadata. So this PostgreSQL database has these tables, and with these tables as like strings, you can create, delete, and like drop queries that you can just like generate like, yeah, don't do that. But if you're just doing like local development, just like do whatever the hell you want, but like just don't do that. It's just too complicated and just, yeah,
So there's a simpler answer.
yeah,
This is only for local development.
yeah,
I want to emphasize that.
yeah,
You either have an ORM, which can regenerate the schema for you, including whatever changes you define, or if you don't have an ORM, you should be manually writing migration scripts, which make the changes you want to make.
yeah,
Just local.
But when you're developing, like, something like proof of concept, it doesn't make sense to create migration scripts every, you don't version database. You just want to run something, like a one-off test.
That's fine.
yeah. ORMs can do that for you. Yeah,
Yeah, so you just drop the database,
yeah,
and you should have DDL recorded somewhere. Even if you're doing like local development, you have a create table statement somewhere.
yeah,
So you just drop the database, edit that statement, recreate the database.
But the problem here is that you're connected to the database, so you can't drop it.
you can.
No. When when you have a live connection to the database, you can't drop the data because you are connected.
So when you're doing your migration script, database setup script, whatever, you just switch to like the information schema, create the database, do your operations, and then switch to the new.
Yeah.
I'll just ask you if there's a simple way.
I mean, ORMs kind of do the job for you, and yeah, and just once you have it set up, it is not that complicated. I mean, as a backend developer, yeah,
Just automation.
yeah, automation. It's all automated. Yeah,
Yeah, create a script to connect to the information schema, drop the target database, and then recreate it with the migration script.
yeah,
It's not the most elegant, but it works.
yeah. So we created a table called customer. It will contain customers. We have products. This time we're going to use a number, just an integer, as a primary key. The constraint, yeah, this is called constraint. This is defining that. Means that it is defining this column as the constraint, as the primary key, and this primary key keyword is just saying that this is going to be the primary key of this database, of this table. Yeah. We put the name, we put the data type as varchar. 255 is the longest for varchar that we can do. And we can say that this column will not allow null values, right? So that's where we will put the not null statement here. And the price, double precision, it just basically means floats. If you're familiar with programming, there are different types of numbers, integer and floats. It's also called double precision in Postgres. Yeah. We also say this is not null. And the description. Text is I think a different, a special like text data type in Postgres. Normally, you can only store 255 length strings, but if you want to go over that, you use the data type called text, right? And this is where the table creation gets a bit more complicated. So I already introduced you the concept of constraints, right? So as usual, we put the ID as the primary key. And the primary key is just a unique identifier for each row that we can use to refer to other rows in other tables, right? I'm going to put a created date as a timestamp to show when the order was placed. And the product ID, this will refer to the product table here. This will refer to this ID. Yeah, so basically every ID that goes inside this column, the database checks to see if it exists in this table, right? So you can't just put in any kind of ID and just hope that it works, because each order must be with an existing customer and an existing product. And we do the same thing for customer. And this customer ID is a UUID that we defined here, the same type. And it's going to make sure that this customer ID refers to like any row in this table. So you can't put a customer that doesn't exist in this table. And status. So the constraints, normally the only examples I've shown you this so far is just like primary key and foreign key. But you can do a bit more complicated stuff here. So what this thing basically does, right, it makes sure that the status of the order is within, it just checks to see if it's inside this array, right? So the status can be pending, in progress, completed, disputed, refunded, all that kind of stuff, right? And honestly, I didn't type this. I just like Googled from a Stack Overflow. It just goes to show you that how infrequently I use the DDL commands, and it's honestly I don't think it's that difficult. It's just creates and just like defining data types, all that kind of stuff. Oh yeah, you can also set default values, right? So this ID, if you put in nothing in, it will just use this function, this built-in function into Postgres to generate the UUID for you. So you don't have to generate a UUID every time you want to insert it to a database, right? So yeah, and this is how a basic like relational table structure is created. Yes.
Is this something to generate UID inside the database or in your platform server?
For the purposes of this example, I'm just using this because it's just, I guess, more convenient. But
The database is usually faster.
yeah,
Usually.
yeah,
It depends, but usually.
it's written in C and C++. It's definitely going to be most of the time, I think, faster. Yeah.
I think that's actually slower because we have to consider that sometimes you need that UID back because that UID might be connected to some other entity. So if you do that on the database side, you still have to fetch it, right? And then once you have the UID, you can create another record in some other table, right?
For individual insert statements, you get back the inserted ID as part of the insert transaction. So you avoid the need for an extra call.
It also depends on the ORM. Some ORMs, they don't return the value right back, and you have to refresh. I just like do the query again and get it back. But I think like small individual like calls like that, they're just not that slow. So if you really want to optimize for that, just like do it on the server or the client side, whatever. But I mean, yeah. But I think the first thing I'll think about when like optimizing like inserts or just like selects is like to put indexes or just how to use indexes, but not about just like small queries that just retrieve IDs, you know? Yeah. So small stuff. Yeah. All right. Oh, there's a lot of stuff. Okay. So when we want to alter stuff, right? Oh, I said if not exists, I think it should be there here. If you want to add a column, I would run this statement called alter table, not coupon.product, at discount. So discount would be the name of the column, and double precision would be the data type, and the default value would be 0, and the constraint that we put in would be, it has to be not null, right? And this is a statement that we would run, right? And let's see. Oh, hold on. Right now, right, we have just like this stuff here, right? This doesn't have the, a discount table, a thingamajig. Hold on. If I run this, it got run, and then product. We can see that a column got created, right? If we want to change the order status to add in a different like status called missing, I would first drop the constraint and then add the constraint again. So this is another way to alter tables so that you can change the constraints. And yeah, And for truncating and dropping, I will get to that later, right? So truncating and dropping, right? So the main difference between truncating and dropping truncating and just dropping is that truncates, it just deletes everything inside the table, right? I will just use this as an example, just truncate, not Amazon. What's it, users, right? It will just delete everything inside. And it just happens really, really fast. But the downside of truncating is that you can't roll back. When things are deleted using the delete command, a log of that is stored in somewhere inside the database. So worst comes to worst, you can just like try and recover the data if you really regret just deleting stuff. But truncating, it just doesn't really care about that and just like clears everything. So if you really need to just like delete something inside the database table, like test data that you're not using anymore, I just use a truncate statement. And dropping, it just means that it will just like remove the table entirely. Let's see if I have the DDLs for the other stuff. Okay. I do have the DDL, so I'll just drop it, right? See what happens. Not Amazon. User, right? If I just drop the table, see the what's it? Data grips detected that user is not a table anymore. So if you try to refresh this, oh yeah, it's not there anymore, right? It's just gone. Yeah, let me just run the query again. Create table. We got a new table, and then I'm just going to insert some data here. Yeah. Inserting 10 million rows, blah, blah, blah. Yeah, this is what truncating and dropping does, right? Now up to insert, update, and delete. Inserting, updating, deleting, I also rarely use these commands. When I need to put in some constants inside a database, I sometimes use inserts. When I need to do very simple data migrations, I use updates and deletes. All of this kind of stuff, it is usually just automated by something called the ORM. In Python, you can use like Django ORM or SQL Alchemy. In TypeScript, there's type ORM. In JPA and in Java, there's like JPA and Hibernate. They usually automate all of this for you because the structure of this these queries are just very, very simple, right? So I just barely don't even try to memorize them. And here. So into customer and products and order, I just put inside data, right? For ID, I just use the default so that I don't need to generate the UUIDs or just the numbers. And yeah, you can put, so it's just basically this, right? And typing all of this out is honestly just quite boring. So I already did this, and inside, yeah, we have data here, right? So inserts, pretty simple. This is just basically English. So, right? Updating and deleting, right? So updating is also, I think, pretty simple. You first say which table you want to update, and then you decide which column that you want to update, and then you can put in filters to decide like which rows that you want to update. So in product, I want to set the DND 5e Clear Handbook as price as $30. For sandwich, you can also refer to the column in the set in the other side of the equal sign as well. I want to increase it by 1.2%, right? And delete, right? Let's try running these queries, right? Update, it ran. So the price should be now 30, right? For sandwich, I think price was, yeah, it was $5.99. Now it's like $7.02, right? Let's try deleting the ukulele. No more ukulele anymore, right? It's gone. Let's try deleting the customer called Beach. Let's see what happens. Oh no, it doesn't have. Yeah, but unfortunately, we're not allowed to do that because the database says, hey, in the order table, it looks like Beach has ordered some stuff, so we're not allowed to delete this. So if you remember to the constraints that we set here, right? So this customer ID, it has to refer, it always has to refer to an ID that exists in the customer table. So when we tried to delete Beach from the customer table, Postgres was like, nah, not happening, and because it has to reference something that exists in the table. So this is how like consistency is managed inside a database management system, right? So this doesn't run, right? Ignore this, right? Altering, truncating, deleting. Insert, update, deletes, pretty simple in my opinion. So this, if you're just running select queries and all that kind of stuff, you may never encounter it in your career. But if you are a backend engineer and you're just doing a lot of like CRUD stuff, the ORM and the database like library is doing most of this for you, and it just makes life simpler. But it pays to know what all this means, right? So I talked about all the way back at the start. Where's acid? Where's the acid? Right? So I talked about something called transactions inside when I talked about like isolation and atomicity, right? A transaction is basically, hold on. Where it is? Yeah. So basically a database transaction is like a shopping trip where you buy multiple items at once, right? Either everything gets purchased and you leave with all your items, or if something goes wrong, you put everything back and you leave, and you just basically end up with nothing, right? That is the concept of a transaction, right? You can like set a starting point and an ending point, and everything has to run successfully so that all the data is correct, right? It's a way to ensure that the series of database operations are either completed entirely or not at all, to maintain the integrity and consistency of the data, right? And to demonstrate this, I'll be running these commands. So what a database like library does in the back end, when you're trying to insert or update or delete something, it will implicitly call this command, begin transaction, right? Begin transaction. Begin transaction. And then I am going to insert something new into the products, right? iPhone 37, this iPhone has no charging port, right? If I select everything from .coupang.products, but yeah, every SQL statement has to end with a semicolon, right? Like C++ or like Java. Hold on. Why is this not working? Did I forget how to do select statements? Well, this is embarrassing.
It's Postgres. You need to connect to that database, and then it's the public schema. So you have to.
Hold on.
You have to. Is not Coupon a database or a schema?
I already connected to the database, so.
Try just products.
Oh wait.
Oh, it's product.
Yeah, it's product. Yeah, it's a stickler like that. Yeah. Hold on. Okay. So if something goes wrong, the transaction is aborted and just like nothing happens. So let's just roll back. Right. Let's. You can see that if something goes wrong in this transaction, just whatever change that you made, it just doesn't get like persisted inside a database. So yeah, Let's try begin the transaction again. Begin transaction. Begin transaction. Insert. And then, yeah, let's try to select again. Let's select from these work. Yeah, we can see that this iPhone got put in, right? But if you roll back at this point, if you try to select again, it doesn't get persisted. Let's try actually inserting it and then committing it, right? And then if we use the commit command, any change that happens between begin transaction and commit is actually going to be persisted inside the database, right? So when we try this again, we're going to see that this iPhone 37 got put inside the database, right? So there is this thing called save point. Question?
Sorry, am I scrolling up or not in the or you can't go like no underscore and dot and then a bunch of stuff and it's like custom.
Yeah.
Some of my important ones is moving
Oh, yeah. The quotes. So strings in SQL, you have to use like single quotes.
sorry, no guys. Mine, can you go toggle it up? You were just in this. Oh, yeah.
Oh, yeah. So, yeah. So in SQL, there are some reserved keywords. Just like in programming language, the keyword for is like a keyword for like for loops. In databases, like something called user and order are just like reserved keywords that you normally just wouldn't use to just define tables. But like SQL is kind of flexible enough that if you want to use like a reserved keyword for something like a table, it just auto puts in like these double quotes to show that this is not a reserved keyword and this is just a name for a table or a name for a column, right? Yeah, that's the difference, yeah. And there's this thing called a save point, right? Let's begin transaction again. And let's insert an iPhone 38, right? iPhone 38. And let's just make it about, yeah, this much expensive. All right, and then let's create a save point. So when we usually roll back everything, right? Huh? Mm-hmm.
Right. This is just because he's doing it in P-SQL. If you're doing it with the driver for a programming language, the result object that you get back from the cursor has a last inserted ID property that you can treat.
Yeah.
You're not going to see it in the
Yeah.
folder.
Yeah. So you set a save points right here, and then insert something else. Let's say a charging port subscription, right? Because I think this is something that Apple would do. We can see that when we select for products, we put in these things, and then when we roll back, hold on, is this? Yeah, roll back to iPhone. We roll back to a save point. I've never personally used a save point, but I'm just demonstrating this because this is one of the transaction control languages here. If we select again, we can see that the charging cable that we inserted is just no longer there. I don't see many use cases for this. So yeah, it may just be completely useless for just like normal devs, like backend devs. So yeah, so let's roll back everything. When we select, yeah, we just have only the iPhone 37 that we put in. Right, and this is the transaction control language. Right, and this is basically all the code that we did. And yeah, query language, this is the most, I guess, complicated part. So biggest tip I can give about select statements, think about what you want to do, think about what you want to select in basically the plainest English possible. I want to select the biggest order from the order table, right? And just by saying that, you already know, just like it's already halfway there. Select from and where, right? And you will use these keywords again and again and again, right? I will start with simple examples, and then I will move on to much more complicated examples, right? So from the products table, right? This star thing, it means that it will select every single column, right? If I just want to select name, I can just do name. If I just select price, I can just do price, right? I'll just do this. And this like, this is a string searching keyword. So and these two percent signs, it just means that E can appear any place inside the string, right? I think this means that it has to start with E, and this means that it has to end with E, right? So when you do this, we will select all the products that contain the letter E inside the name. So widget, shoes, blah, 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 iPhone. If you want to compare numerical values and compare several different filters at the same time, we use these just, greater than, less than stuff. If you're familiar with programming, all of this like filtering stuff would be very easy for you, yeah. All that kind of stuff, greater than 20, less than 90, right? If you want to check specific values, we can use the in keyword, right? This is very similar to Python, I think. If you want to check if X is inside a list, you will use the in keyword here. So if the status is inside refunded or completed, we select it, right? From the table called order, right? We do this, you'll see that these are the orders that are completed or refunded. And this can be also done the same way like this. We can use the and keyword. I hope I don't have to explain what and is. It means that both of these conditions have to be true. This or means that either of these can be true, right? So this can be also written as this. Why would you want to write it as this? It has to do with how databases like search through columns and how they evaluate these statements, right? So what a database may do, right? If it receives a query like this, right? It can do something like this internally. It can run these two queries like in parallel at the same time, and then join the results and just like return it to you. Because doing one query like this could be just slow, but just doing two queries like this, it could be faster. And the database can determine if it wants to do it like that. So how the database works, it is getting too much into the weeds, basically. Yeah. If I run this query, it's going to be the same as this, right? Yeah, same result. We can do direct comparisons with equal signs. Customer with the name Beach. Right. Now we can get into joins. Joins could be difficult for some people to understand, right? I had a good explanation written somewhere. So a join is like combining information from two or more tables based on a related column. And this is where all the related column stuff that we defined here. No, not here. Here, right? It references product, it references customer, right? For two or more tables based on a related column. So it's similar to matching pieces from different puzzles to create a complete picture. And by joining tables, you can retrieve data that's spread across multiple tables and present it together as a single result set. So what I have here, I am going to first select the name from customer, and I want to see what each customer ordered, right? So I will join, just ignore this at the moment. ignore this. I'll join order to customer, right? And what I have here are table aliases, right? If I don't have this, right, I have to type out the full name of each table, right? And that could get tiring if the table names are just very, very long, right? So this is just like convenient stuff. Oh, yeah, question? No, this is just selecting. No, you're not making a new table. Yeah.
So you can think of a join like selecting data from two different tables and then just putting that data together and then displaying it as if it was a new table. It's
Yeah.
a new table. Now, internally, what the database engine does is it creates what's called a virtual table, so that it can just work with the data easier, but you don't need to worry about it.
Yeah. Is anyone familiar with Excel? Yeah. Is anyone proficient with VLOOKUP? Yeah. So if you are proficient with VLOOKUP and index match, join is basically what that is doing. Did that make sense to anybody? VLOOKUP. Okay, maybe not. But it looks like it's creating a table, but it's not. It's just like literally just joining two things together and just showing you. So I'm going to run this query, right? We can see that Beach had 3 orders, Jay had 2 orders, and Alex had 1 order. But we can see from the users table, from the customers table, that we have 4 customers, Beach, Jay, Alex, and Kyle, right? But what if we want to see Kyle as well? But before that, let me just explain what it is, what this query in just like more detail. So we say we want to join customer to order, but the database doesn't necessarily know how to join these 2 tables together. But because we have the foreign key in order called customer ID that is referencing the ID in the customer table, we can say that just join these 2 tables based on this column from these 2 tables. Yeah, this is what this query is saying. And from here, we're only selecting one column from customer and all of the columns from order, right? And to get back to my point, there are no questions. If I want to see Kyle as well, right, I can do something called a left join. And what left is referring to in this case, it is referring to this table called customer, right? Left join, right? It means that it will try its best to get everything from order that matches all the customer IDs here. But if there's nothing, it will just display null, right? See? It selected everything, but since Kyle didn't have any orders, it refers, there's just nothing there, right? Left join. And this left here, we read left to right. So if this was just like one line like here, like honestly, like queries, if they don't need to be formatted well if you're just like, if you just really don't care. So this left here refers to this, right? It refers to this table, right? Yeah.
So if we think about joins kind of like constructing, let's not say a table, let's say constructing a results set. It reads from left to right in terms of the logic. So left is the results set you built up so far. Because you can have like 20 joins, right? So as you build up a result set, whatever's on the left, if you do a left join, is going to stay there and then stuff to the right is optional. So left is not necessarily the table immediately behind, but it's your total result set up until that point. Does that make sense?
So when do you use the right or left?
So left is if you want to keep the result set that you have so far, and then if there is something to join to it, go ahead and grab it. Right is you don't care what you've done so far, grab what's next, and then if there's nothing matching, throw it away.
I think
Join without left or right is an implicit inner join where both sides must match up or it gets thrown away.
So if I were to like change the order of how this is done, right? If you want to select stuff from order, and customer, and we do a right join, we get the same result. We want to keep everything here and just join it here. And I'm going to copy this again. This statement and this statement are basically the same thing. So how familiar is everyone with set theory, Venn diagrams? So if we have two circles, right, the intersection point, this is basically what it's getting, right? If you have two circles, the intersection point, this is this, and this is that. Yeah, both will just do the same thing. If you do a left join, in this case, right, it will take the intersection here, as well as everything on the left in the Venn diagram. Yeah. This will also do the same thing because we put the tables in a different order. Let's try a right join. It's probably going to be the same as this. Yeah, we're keeping everything from here, and we don't care about this. So yeah. And this is joins. And yeah, just play around the queries, and it will just become natural to you. No questions? No questions. Okay.
So again, right join includes the intersection.
So the intersection, only the intersection is inner join. Left join, right join will include the intersection. So can you pull up a diagram real quick in the browser? Actually, maybe if you search Venn diagram SQL joins, maybe there'll be a thing.
Oh, there it is. There it is. Yay. Yeah. Left join, inner join, right join. You don't need to worry about this stuff yet. This is basically it. Left join, inner join, right join. Yeah. So it turns out middle school math was important at all, you know. You know.
Does anyone have questions about that?
Yeah. What do you mean same?
So the Venn diagram is referencing the values in the on part. Okay, so you say join table on field from one table equals field from another table, right? In the case where the two fields match, that's the middle part of the Venn diagram. Okay, so go back to the diagram. So that in that one, the red bit is where on x equals y is true. Okay. The left one, that's where x equals y is true, or there's just x. Okay. The right one is x equals y is true, or there's just y. No, what is still not clear?
Column can be different from table, right?
Column is a part of a table.
Yeah, so the number of columns or the name can be different, right?
Between tables, yes.
So if you join them, how do you
So that's this on right here. If you see customer.id equals order.customer.id, those column names can be anything. It doesn't matter what the column name is. It's just checking the value of that column for a given row to see that the values match.
But how do you deal with duplication?
It duplicates. It just duplicates. So if you run your inner join here,
So when you do an inner join, let's say
So, right. So, your customer table only has like what, 3 or 5 records or something? You'll notice that name is coming from customer, and we have the same customer 3 times. It just creates a new row. It just duplicates the data. Does that make sense?
No, no, no.
In storage.
In storage, there's no duplication. You're just reading from data. Yeah. Yeah. Reading and storage is very different. Yeah. When we read, like for UIs and stuff, when we want to like give data back to like the clients for rendering and all that, we're fine with like duplicate data, right? As long as the data is stored correctly, we don't really care.
Right.
Yeah.
So what happened is, when it pulled from the customer table on disk, it read this bead record once, and it read it into memory. But now that it's in memory, it can copy it 3 times like that, because memory's fast, right? So at read time, we don't really care about duplication, because once we read it from disk, it's in memory, we can just go. But on disk, you want to limit duplication to limit disk reads, because disk reads are slow.
Yeah.
Does that make sense?
How do you reconcile with that? Say, first you see the first one you put, and the other bunch of people,
I don't understand the question.
If you want to select one, you just select one.
just select one. So let's say, like, for instance, somebody is looking in the database, looking for just the one user. For this case, they're using like a lecture or something like that. And that happens like there's lots of duplication happening.
Yeah. So
how
go
do
to
you-
your inner join here, and add a filter for name equals beach.
Yeah. So you can.
Customer.name maybe.
Oh yeah.
Or order doesn't have.
Yeah, it
Do
doesn't.
you have like a filter kind of like something
Yeah.
on this by name?
So you can filter any way you want, right? You can filter by any column in any way you want. So here, all this. This is a name. This is a string. I can use the like filter. For price, I can use like these signs, all that kind of stuff. So all the yeah,
Let me explain it differently.
yeah,
So the where, that triggers filtering mode, right? Where is filter? When you hear someone say filter, they mean where, okay? Now, in normal programming, we are used to something equals something, like variable name equals value, and we treat that as assignment, right? With normal imperative programming, the equal symbol is an assignment operator, all right? Assignment is what we're actually doing, not equals, it's assignment, right? But in SQL, the equal symbol does not mean assignment. There is no assignment in SQL. Well, at the basic level, there is no assignment in SQL, all right? In this case, equal is a filter. If we were to convert this to like normal programming like JavaScript or Java or whatever, it would be a double equals, all right? It's comparison. So what we're doing is, we're saying that for a given row of the customer table, I want to check if the name field, if the name column for that row has a value of the string beach. And I want to compare the value of the name column for that row to the literal value beach. If that comparison is successful, grab that record.
yeah,
Does that make sense?
yeah. So think of the English statement first. From the table customer, I want to select everything that has the name beach, right? The select is this select, and everything gets translated to this. And this is like from this table, it becomes this. And the name that has the name, so this is basically a filter, where becomes this, right? It is just English, but ordered weirdly. Yeah. So right now, this is just selecting everything, but you can combine all of these things together, all of these joins and wheres to get exactly what you want. And this is what I'm doing here, right? From this customer table, which I'm going to call C, this order table, which I'm going to call O, this product table, which I'm going to call P, just for like convenience sake, because I don't want to type everything out. It's annoying. From customer table, I will select name. From the orders table, I'll set quantity, and then I'll also select status. And from the product table, I'll select name and price. But how are you going to join all of this together, right? From the order and the customer, I will join based on the order's customer ID to the customer's ID table, right? From the order's product ID, I will join to the product's ID table to get all the product data. Because when we did this, right, it only joined the order and the customer table, right? So we don't know exactly what product they bought. We only know the product ID, right? So if you select this, and I want to see what Jay ordered, so I'll do this, put the filter here, right? We can see that Jay has bought some widget and some shoes. And the widget is in progress, and the shoes have been completed, right? And this is how we can just like get exactly what we want using like select statements, right? So this is not creating a new table. This is just reading, right? This is just reading from disk. You could write a script. You could write a script that connects to the database and parses the CSV and then creates a insert statement like this. And then you can just read from the CSV, split by the comma and just put everything in here. That's a method.
So wait, are you talking to export or import?
Like I have my CSV, just want to dump it.
You want to import it into?
Yeah.
I forget. I imagine Postgres has an operation for it. I forget the name. I know MySQL has something like a load in file, and you just provide a CSV and it works. I imagine Postgres has something similar, but I don't know off the top of my head.
Yeah. 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 Something like that. Yeah, I barely just interact with CSV files, so I don't know. Yeah. But before you import the data, right, you have to create a database and create a table and just define what each column is and what type of data it has to store. Otherwise, you just like try to slam it all in. Postgres is going to go, no, it's not allowed, So yeah. And so group by. Oh man. So we can see that each person has ordered something different, right? Beach, Jay, Alex, they all order something different. But we want to, there's a lot of like duplicate data, but we want to aggregate all the results. We want to see what the most expensive thing Beach has ordered. We want to see what the most like cheapest thing that Jay has ordered, something like that, right? And we can use something called a group by. So we're going to try to find for this query. So this has all the joins, right? This has all the joins, and we want to see people that have more than one order, right? We can see from here that is Beach and Jay that have like 2 and 3 orders each. But imagine if the table is just really, really long because you're working at Coupang and they have like a bunch of fucking orders, right? So we're going to group by the customer's ID, right? We want to aggregate it by customer, right? And because we set the primary key as this, and this is the unique identifier, we want to group by this, right? Group by is like putting items with the same characteristics into separate baskets, right? And I'm going to first do this. I'm just going to delete this, just like comment this out, right? We can see that Alex has ordered 1, Jay ordered 2, and Beach ordered 3 things, right? So what this thing does, right? It put each data into like one bucket each, right? Each customer into one bucket because we're grouping by the customer's ID, which is unique for each customer. And we counted like how many rows there were for each customer, right? Because if we just do this, let me get rid of this, right? we can see that there's 3 rows for Beach, 2 rows for Jay, and 1 row for Alex, right? But if we do this, it just does it for you. This count function, it just counts how many rows there is for each customer, right? Right. But if you want to filter by this aggregated value, right? We normally use a keyword called where, but now we use something called having. I don't know why they chose this word, but they just chose this. So yeah, we're going to join all this. So what the database is going to join from here is going to join all this. It's going to select that. After it's selected all of that and joined all of that, it is going to group by the customer ID. After it put each customer into each bucket, it is going to count how many orders each person had. And after it did that, it's going to filter from this result, right? It's going to filter from here, where the count is greater than 1. So the actual execution of like the commands is not exactly within this order, right? So let's see what happens. You're going to get 2 rows. This happens last, so we were able to just get only these 2 rows because we filtered from the result set. So it just makes a result set, and then it does a lot more operations on that, because after it got the data from disk onto memory, where it's much faster to manipulate, it did the filter again, right? Yes, question?
There are 2 count rows, right?
Yeah,
So does it mean that the database is counting the records twice?
yes.
Do the operation twice, the first pass and the second pass, but it's counting the same thing.
It would be cached, so it would be counted a bit faster. But yes, I believe it is counting twice. Yeah.
And why can't we use where in there?
So since like this, so basically since this, right, this orders count, this column here from the like results set is not actually a column in a table. It can't really refer to it using the where keyword. The where keyword really only refers to actual like existing columns, right?
So having
Yeah.
can be applied to the aggregated data.
Yeah.
Yeah. Or
No,
you
the-
can still apply where to join data.
Yeah.
But this grouping and counting,
Yeah.
that's an aggregation,
Yeah.
and having only works with the aggregation.
Yeah.
So if you wanted to do something like an average, right, that would have to be across an aggregation, so it would have to be as part of having.
Yeah.
Because the count of things is not a value in the database, right?
Yeah.
It's something it has to calculate.
Yeah.
So the having takes place after an
Yeah.
aggregation calculation. Does that answer the question?
So speaking of averages, this just calculates the total spending for each customer, the sum of price and quantity, and we name it as total spending for the result set, and the average for each customer using the average function. And these are all just like built-in functions within Postgres, right? And if you just want to do the result set filtering again, all these aggregated values, having average spending is greater than, I don't know, price, quantity greater than 200, right? We can see that Beach is the biggest spender. Oh, no, it's Alex. Oh, wow.
I'm broke.
Wow, Alex is rich. So, yeah, this is how you do filtering based on these aggregated records. Yeah, this kind of filtering is special and is actually like pretty slow, considering that this data has to be calculated every single time, right? And this is the, like I just crash course on selects, and it can get pretty complicated depending on how many tables that you have and what kind of data that you really need to query from. And now, do we have time? I guess we started at 6:15, so we can like stretch on a bit more because I want to talk about indexes. Right. Indexes. Indexes. Yeah. Right. Hold on. Indexes. So to set up the demonstration for indexes, I created a table and from this table, I inserted 10 million rows. You don't need to know what this does. I just found this on Stack Overflow and just like changed it a bit. And this here, yeah, there are a lot of rows. 10 million, wow, so many. I wish I had $10 million. And from here, I am going to also demonstrate the explain analyze keyword to show you how Postgres like decides to run the queries that we're actually just like shooting off into the database, right? Explain what this does. It shows the internal like logic that Postgres uses to determine how the query is going to be run. And analyze means that it's actually going to run the query and show you how long it took, right? So if you try to select everything from user and explain analyze this query. So what a database management system does when it gets a query, right? It takes some time to plan, right? How am I going to execute this query? Because this query can be executed in many different ways, as I will show you with each example. And it actually just runs the query, right? And this is 0.5 seconds. So it took this much time to plan and this much time to actually run the query, right? Yeah, it is slow. So we got familiar with the where filter with here, right? And a database, when it does like a where filter in the most basic sense, it can do it in a couple of different ways, right? We can see from here that this is the primary key. And a primary key, like internally inside a database, is stored differently than like, because it has an index. I'll explain what an index is later, right? Internally, it is stored very differently from the name or the age column, which doesn't have an index, right? So when we do this, it's going to be decently fast, right? It did something called the index scan. So the planning time was 0.3 seconds, and the actual execution time was 0.179 milliseconds, right? Very, very fast. So what is a index, right? I think it will be database index, right? Database, E-tree index, right? So who is sort of familiar with data structures and algorithms? Sort of familiar, kind of. Okay, so let's see, array. I'm going to give a very, very short explanation on just like a searching time in a data structure. So this user primary key, since it has an index, the data is stored roughly something like this, right? Roughly, right? Not exactly like this, but just roughly. And the name and the age, since it doesn't have an index, right? It is stored roughly something like this, just a list, right? Just a simple something long list, while an index, it uses a tree-like structure, right? If I were to find something inside a list, I would check every single one, right? I would check every single one and it would take a long time. But if I were to search something here, right, it would be much faster. And why is that much faster? Because how a tree stores data. It stores data based on like data comparisons, right? B tree index, integer, hold on. Yeah. So let's use this example, right? If I wanted to search up the number 4, right, inside the data, if it were like stored something like this, I would have to go one by one. I would check 1, this is not equal to 4. I check 2, it is not equal to 4. I move on, right? And it would take maybe 4 iterations, right? Here, if I want to search up the number 4, you can notice that numbers smaller than 13 are stored on the left side, and numbers larger than 13 is stored on the right side, right? I know that number 4 is smaller than 13, so I go on the left, right? I know that 4 is smaller than 9 and 11, so I go to the left. And then from here, 1 to 4, I know that this is stored in a ascending order. So from here, I check here, and I get the number 4, right? But so since the number 4 is small, the number of times I had to search is basically the same. But if I had to search up the number, let's say 25, right, inside a data structure like this, which is just like continuous, I would have to check each and every single entry in the array like once. Like, is 1 equal to 25? No. Is 2 equal to 25? No. And I would have to do that 25 times, right? You can see how that is slow. But if I go here, is 25 larger than 13? Yes. I go to the right. Is 25 larger than 16? Yes. And from here, I can see that, I compare this, this, and this, and I only have to compare 5 times compared to 25 times that I would have to do with a data structure like this. Yes?
Yeah, so if you go back to that,
Yeah.
so say you have some complicated data, like
Yeah.
plenty of ones, plenty of fours, and plenty of nines, only 3 kinds of numbers, right? Then this doesn't work very well, right? And how do your indexes then?
Beach has something to say.
Or you can answer first if you want.
So each in a database, right? Each primary key has to be a unique value. So there can't be like duplicated data, right? So first of all, there can't be any duplicated data. And if it's just something small like this, like it would be just a very small tree. So if there's like only 3 values, you put maybe 4 here and the 1 and 9 there.
I mean, like, you will have like 10 million records. But
Yeah,
each record has either 1 or 9
yeah,
in some of the columns.
Yeah.
Some of the columns.
yeah.
So this index would still be like 10 million boxes, right? But the box would only contain either of these numbers,
What?
right?
We don't answer the question.
So you have a column with n, right?
Yeah, yeah.
And it can have like 4 different distinct values.
No.
No.
Oh, you mean across the table or within a record?
Across the table. You can
Okay.
have
Yeah,
columns.
okay.
So this renders the whole tree like very efficient because you have to still plenty of like same numbers. So
You still get log n performance. Similar to like a binary tree, right? It actually provides a little bit wider search space than a binary tree. But
let me guess simple case. Say you have a Boolean value in one of the columns, either true or false. And you want to filter by, right? So you have 5 million rows with true and 5 million rows with false.
right.
And how do you do it fast?
I mean, so let's say you're pulling the number 9, right?
Yeah.
9 is just the value that you're searching for. You can think about it as like the key, right? But then what's stored behind that 9 is a reference to the disk location of all of the records that have that 9 value. So even if it's just like a Boolean field, you're going to have that whole set of records that have that Boolean value.
Is it still going to be fun?
So it depends on your query. If you're fetching the entire set, obviously no. But if you fetch any one with a value of true and then you say limit 10, it'll be instant. It'll just grab the first 10 and leave it.
So to explain a bit more, the purpose of an index, so basically so a database essentially is a program that's really just specialized in storing and retrieving values, and how the data is stored inside like a disk, like actual physical disk, is honestly going to be quite random because we don't know, because the OS doesn't really know or care like which like actual physical location it is stored in, right? And it only just cares about the memory addresses, right? But if we have an index to at least point to values that, so it doesn't really know actually where it is. So it has to do a lot of like random like access inside the disk to find everything that it needs. But an index which points to actual certain values will stop all of this random access that goes on to the disk. So it will just speed things up considerably. Yes. According to a book I read, like the actual like physical like bits and bytes inside like a SSD or stuff, it is apparently quite random, right? Like how actual like memory is stored, because a lot of like this goes kind of beyond the scope of this, but the actual memory storage is actually quite random apparently. Yeah, so that's why it just can take quite long to retrieve things. So that's why we use stuff like RAM and pointers to actually point to places in memory where things are specifically located in, right? Yeah. Data is going to be chunked up by the OS to like be stored in like different places. But anyway, that's just too much stuff, right? So this data structure is more efficient than this data structure when searching for things. That is the entire point, right? That is the entire point. So when we search by this is fast, right? But when we search by this name, it doesn't have an index. Ooh, that's spicy. That's spicy. So Postgres is being smart. It launched 2 worker processes to do things much faster because we're all in a rush. So it has like 2 like processes running to search through all of the records and to see if each name is equal to ABC. So it checked through every single row and just like returned that to us, 0.2 seconds. And that is slow. And that's why we usually put indexes to make like searching a bit faster, but that is also like a nuanced topic that I want to briefly demonstrate. So we know that this ID has an index to make searching faster, right? Right, it's fast. Even faster than before because the result was cached and it just used the same thing. If we do this, right, this also uses an index, right, to search through things and find things that are less than 200. But since we know that this table has 10 million rows, right, and Postgres also knows that, when we run this, where ID is greater than 200, Postgres is just going to do a sequential scan. Like, they see no points in trying to use an index because the result set is just too large. So they'll just check everything, right? Right. So just because there's an index, it just doesn't mean that Postgres or any other like relational database management software is actually going to use it. It's going to choose the best possible like execution method according to the kind of filter or just like query that you run. Yeah. So indexes are not the magic bullet. Where you put the index and how you put the index and what kind of queries you run, that really just is an art in itself, which is just very, very complicated and I don't have enough experience on. But it's just like not easy, right? I'm going to show you why like searches are also terribly slow, right? Even if we put stuff like name, right? Even if we put stuff like this into here, right? That allows like fast comparison. Like queries, we have to because we have to check for substrings, it does have to, like, it will ignore the index and just check everything, right? And that is, yeah, quite slow, like 0.7 seconds, too slow, right? If we try to order by stuff, right, order by is going to be even slower. Yep, that's taking a lot of time. Ugh, disgusting, disgusting. Yeah, this means like, I think this means all the disk hits, parallel sequential scan. Yeah, they didn't, yeah. It's just, so, yeah, this is why just, querying and optimizing and all that kind of stuff is a really deep topic that I don't really have time to like go into, but it's just, yeah, when I said that squeal is, SQL is going to make you squeal, like I meant stuff like this, like, yeah, indexing and selecting and making things go fast. And this is why you have to know like how databases actually, interpret and run the query beyond just like selecting things willy-nilly, right? And you can use this explain analyze keyword to do that. And I think that's just about it. It's 8:16. Yeah. So, yeah, thanks for listening to my ramblings. This is my sort of introduction to all this database stuff that I've, from all the 2 years of experience that I have, I guess. And then we covered all these things. And, further topics, how do databases work internally, pages, cursors, all this like worker stuff, how do you optimize them, how do you write efficient queries, and, and how to do database administration, because that's like another big field in itself. And additional resources. This is a website that I use to learn basic SQL at first. And I think the official Postgres docs are okay, but I find myself going to this website a lot because I think, it's just explained more simply there. Book recommendations. If you want to learn more about data modeling as a backend engineer, you will do a lot more of that in your job when you have to like build new features and create new tables and create new relations. You will need a lot of data modeling skills, and I found this book very, very helpful. And the final one is called usedindexluke.com, and it talks a lot about how like just enough database optimization for a developer to know, right? I think, yeah, let me just go to the site. It's really short. The book is really short, and it's just really, really practical, right? Anatomy of the where clause, blah, 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 blah. I recommend like after people like, got, yeah. After people got the hang of like basic select statements, I think it's okay to just start with select statements and just like forget everything else, because select is just honestly, I think, the most complicated part of SQL. And then you can just read this, right? And I think this will just explain things, explain stuff about database optimization in a much more experienced way, because this guy is apparently like a superstar DBA, right? Yeah, he knows this shit, right? Yeah, this guy, super smart. Yeah. Yeah, and that's it. That's it. Thank you for listening. I am thirsty. Yeah, yeah. I'll put it inside.